First, make sure that you know these essential parameters. So at first, empty latent, creating empty space or empty image for us. Let me check what is inside this latent. Okay, preview image, right click and select queue selected. Because I have installed the RG3, I can queue selected prompt. Okay, this is inside the latent. When you're clicking here, you can see that the numbers go up 8 by 8. And this is the rule. You should remember that every image or every latent dimension should be divided to 8. Okay, so this is the reason. Okay, now I have added the HyperST LoRa 8 step only for make some faster test, and I will active the queue and change and pressing the prompt. Okay, now I want to play with denoise. You can see when I am decreasing the denoise, the color that is in the image will be similar to the color that you can see in the preview of the latent. Okay, and actually this is the reason, because actually it's an image that is sending to the case sampler, and you can see that here. Now let's move to image workflow. Let me add VAE encode and connect the VAE here and send the image to the latent, and also change the prompt cat with red eyes. Okay, and let me increase the red eyes value. Okay, now if I decrease the denoising, you can see that the image will be more similar to my image, the rendered image. Okay, and you see if I decrease the denoising, it will be more similar, and if I increase the denoising, it will be more different. All right, every time that you are sending an image to VAE encode and decode the image, you will lose the quality. Let me show you. Okay, here I have the image. This is VAE encode, decode, and this is the image after doing the VAE decoding. And this is a node from RG3 for comparing two images. So this is my original image, and this is after coming out from VAE decode. And easily you can see that we lose the quality and details on the carpet and also on the floor. And if you look to here, also you can see the drops of the quality. So every time that you are sending image to VAE and decoding, you will lose some parts of the image. You remember that I told you the widths and heights numbers should be divided by 8. Now it's fine, and between left and right they are equal. If you check, you can see the output is 1024 in 1024. Now let me change the input size to some other number that are not able to divide by 8 and queue the prompt. Okay, and open the image, and you can see that it's not I defined 1028 in 1020, but it's 1024 in 1016. So the latent automatically will change the size of the image, and it will select the size that will be able to divide by 8. So every time it's very better to send the image with correct size to the latent, and the size that the latent can accept them without doing any resizing. Okay, now imagine that you can adjust the denoising only for part of the image. For example, like this. Let me right click, open in mask editor, and select the hands and also eyes. Okay, and save that. And just imagine that it was possible to do the processing only for these parts. Okay, it's possible, and we have some different solutions. And most of them are related to this VAE encode node. The first node that can do that for us and send also the mask information to the latent is VAE encode. You should connect the pixel, and also you should connect the mask and connect the VAE. After that, if I use this VAE, you can see that it will only process the masked area. And now if I change the mask area, okay, and for example, adding this part of the image and click save and save node, you can see that that area will be replaced. Okay, so this is the most simple way for doing inpainting. And for example, let me select the head of the cat and cube prompt. Okay, you can see, for example, it's trying to replace the head, but actually the perspective is not perfect. Also, don't forget to check the output. Okay, so I want to see that what is the output of this node. So I have to connect the VAE and preview image. So you can see that it will remove the image, and after that the sampler is processing the image. The second node that you can use is using the set latent noise mask, and for using this also you need the VAE. Okay, so at first the output of the VAE will go into the sample, and also you should connect the mask here, and after that you can send the latent to here. And again, you can see also it's working. But if you want to use set latent noise mask, also you have to use the VAE encode, because this node doesn't have any VAE. Okay, and you can see it's working. And if I change the mask area, okay, firstly you can see the result. All right, now let me check the preview of these two nodes. Okay, this is the preview output and preview image. Okay, with latent noise mask, you can see that the image is complete, and it is different by VAE for inpainting. Okay, this is VAE for inpainting, and this is the set latent noise mask. And I think it will send the information for the masking in different layers, and also it will keep the information of the image. So by this technique also you can use denoising. Let me explain to you. For example, you have this cat here, and if you are using this node, set latent noise mask, then you can decrease the denoising amount, because you have the information under the mask. Okay, it's very, very important to remember that. But if you use this node VAE encode, after that, if you decrease the denoising, you can see the gray area, and it was dependent to the output format. And also for inpainting model conditioning, also let me connect the output. And okay, great. Also the output of this node is complete, and it keeps the information of the image. So if let me connect that to the sampler. So now if I play with denoising, I can see the information under the image. So actually these nodes, these two nodes, are much more better than VA encode for inpainting. Also, there are two extensions for doing the inpainting. The first one is ComfyUI inpaint node that is implement the focus inpainting, and you can use that with SDXL. You have to download some models and use this node. And also there is another one that it's very, very new with the name of ComfyUI BrushNet, and also it implements two different techniques, BrushNet and PowerPaint. And actually it's also very, very interesting, but it's working with same concept. Okay, it's another example. This is my prompt, busy downtown area. And you see that only I'm using the inpaint model conditioning, and this is my image. So let me define the mask area. Open in mask editor and define some area in my mask. Okay, it's fine. Save the node and press Q. All right, you can see the downtown area on the left part. Okay, let me do another thing. Open in mask editor. Here. Water, lake, and Q prompt. Okay, this time you can see some water, and also you can see the reflection of the house inside the water. All right, now I want to find a solution for blurring the blending edge. Okay, so I'm clicking on the output of here and searching for blur mask, or actually this node from layer style can work better, and I can increase the blur amount. And to see that how much is it, I should make a preview, right click and Q prompt. So this is the blurriness that it want to apply on the image. So let's see the result. And do you think is it possible to make it blur or no? Oh, I should connect the mask to here and again process the image. Okay, it makes some kind of blurriness, but actually the quality is terrible. Okay, now let me introduce something. If you're sending some blur mask to the inpainting node, after that you can use differential diffusion. Okay, you should search for differential diffusion node and connect the differential diffusion to the model. Okay, this is the magic. This is the magic. And now let's see the result. Okay, you can see that it's trying completely to blend between left and right part of the image. And if you see the processing, you can see it will start from the right and go to left. Okay, the right is completely white and the left is completely black. So this is the reason that now you can have some blending between left and right with some correct concept. I made this with same concept. Okay, here is differential diffusion and this is my mask. Okay, but the only thing that is different, I extract this mask with some preprocessor. I extract the depths, and after that I did some brightness adjustment and I invert that. So finally I sent this mask to sampler with inpaint model conditioning, and this is the result. Now let me turn off the invert and show you how the image is, and this time cue the prompt. Okay, now it's starting from front and going to the end of the image. Okay, and actually the bright area can define the limit of growing these flowers. Okay, here you can see. So this is the concept of the differential diffusion. It's working based on grayscale map that we are sending to the latent, and it's really powerful, and it can change many things. Also, don't forget that I am using a normal checkpoint. This is a normal checkpoint. It is not an inpainting checkpoint. So if I increase, it can go higher. And if I invert that, invert the mask, okay, after that the effect will be start from the white area, and it will come into the image. Okay, we have it here. Okay, so I hope it can help you, and it's very important to understand the concept behind the scene. Now I changed my checkpoint to normal SDXL, and here you can see that actually the blending between the inpainting area and the image, I think, is not very perfect. So if I want to check that, and if I want to make sure what's the problem, actually I think it's related to the checkpoint. Okay, and here, for example, you can see there is a very high contrast between this part and end. And if I change the brightness and start that, after that you can see some better blending. So for example, in this SXL checkpoint, it's very sensitive to the hard edge that you can see in the mask map. And if I change the contrast, let me say, for example, and make it an image like this, I think it will be more smoother and better for STXL checkpoint. Okay. Okay, it's going now. Let me increase the brightness. So for each checkpoint, maybe sometimes you should spend some time to define the best coloring. Okay. Okay, now it's working with image. Now if I invert that and cue prompt, okay, it is working well with image, and I can see that it understands the concept and depths of the street. Let me increase the contrast. Okay, here you can see some edge and border, and for example, let me cue. In SDXL, I think it will completely stop here. Let me start the processing. So after doing some test and having some experiment, you can understand where is the edge. For example, for the SDXL, the edge I think is located here on this area and on this color tone. And if I make some lower contrast, okay, after that the rendering should have more smooth blending. Okay. So remember to play with brightness and contrast of your mask map. Here I have another example that can show how we can improve image with inpainting technique. This is the image that is generated, and you can see we have many problems in face or maybe on the glasses. And now I want to fix these changes with inpainting technique. At first, let me click and copy the image as clip space and add a load image node, paste the clip space and open in mask editor. And for example, select the area that you want to do painting, and you have to send the image to KSampler with inpainting. So I prefer to use inpaint model conditioning node. Okay, so again I should connect the positive, negative, VAE, pixel, and also mask. And after that, you know that positive, negative, and latent. So now if I press Q, you can see it's trying to generate another face, but still it's not perfect, and we can see some problem in the face. So at first I decrease the denoising amount. So instead of generating a new face, it should try to recover the previous face, but still I have some problem. Okay, so what's the problem? Because actually it's trying to generate a face in some little space, and we need a bigger space for generating and fixing the face. Let me show you. For this part, I have tested many different ways, but the best node is coming from layer style. And if you install the layer style on your ComfyUI, it can help you. Okay, so if you click on the image and search for crop by mask V2, it will do that for you. And actually get a preview and Q. Oh, also I have to connect the mask. Now, if you look, you can see that it will crop the masked area and it will add some extra space. Okay, you can see this 20 pixel on top, left, and bottom. Okay, and if you open the image in new tab, after that you can see that the dimension of this image is very small. It's 160 in 176. So actually, I think it's not suitable for start processing. So I will increase the dimension of this image, and let me do that. For this situation, the best node is coming from layer style, and this is image scale by a separation V2. Okay, and after that you can select the scale to side and you can select the longest, so it will increase the size and will fix the longest size with 1024. And now if you check the preview, you can see that the dimension of this image is 928 in 1024. And also it can upscale both mask and image together. And also if you preview the mask, you can see that the dimension of your mask also is increased. All right, so now we can connect the image and also the mask into Inpaint model conditioning node, and we can queue prompt. So after loading the checkpoint, okay, here you can see that it will fix the face for us, and now the face is fixed. But now we have to find a solution for mix the output with original image. So for merging the output with original image, now we need two additional nodes. Okay, the first node is, let me show you here, restore crop box. Okay, and you can see the crop box information from this node, so it should connect to this node, and after that it can work. But it needs some image, the cropped image, and the cropped image should be exactly with the same size that we sent the image to image scale by ratio. So I have to find a way for downscaling the output with same dimension as it go out from this node. So here I have to use another node for scaling, and this is image scale restore v2. So for this one, I can, let me delete these previews. I can connect the output of the image to image, and also I have connected the mask, and this is the mask, and the original mask will come from this node. Okay, and after that it can scale the image for us. Let me show you. Now if I check, you can see the dimension of this image now is very small, and it's in the same size as we had here. Okay, now I have this image, and also this is my crop box. I have connected the crop box, and I have to connect the crop mask also. I have to connect the background image. This is my background image. And also I have to connect the cropped image that is coming out from a scale restore. Okay. And now if I preview the image, you can see that the face in this image is restored. Okay, so this is the solution. Now I can copy this image into clip space and paste it here. Okay, and this time I can select some other face. Okay, and click on save node. And yes, let me see what will be happen here. Okay, also these faces are fixed, and if I queue this node, you can see it will try to replace these faces. I can do this also for other faces. Open in mask editor, and for example, let me select these three faces together. Maybe it can work. Save to image, and this time queue prompt, so it will do all the things. Okay, they are a little better. And this is the final image. If you like it, you can copy, clip a space, and again paste it here. And this time, for example, let me fix the dishes. And last, let me fix my prompt. Table and glasses. Okay. So you can see this time it can help us to fix the issues that we had here. So actually this technique is very useful. If I want to review with you, it is starting by cropping. Okay, and if you crop some part of the image and click and preview, you can see that it will crop the mask and it will add some padding area. After that, we will scale up the cropped area with this dimension, and we will send it to the sampler. After that, after processing in sampler, we have another node for scaling down and make it with the same size as was in original size. And finally, we can send the image, the fixed sized image, to another node with the name of restore crop box, and it will replace the image for us. So this is the process that we have to do for any kind of inpainting. Now I'm working on refining, but maybe you want to work with outpainting or something else. Actually, this technique can help you, and it will save your time, and also it will increase the quality. This is another example. Okay, I have loaded an image, and if you check, you can see the dimension of this image is 4000 in 3000. So it's a very big picture. And I want to add a car here. So open in mask editor, select mask area, okay, and save node. And in my prompt, car parked in front of house. Okay, and you know it will crop, it will resize. So if the image will be smaller, it will fix it on this size, and also if the image will be larger, it will scale down and fix it with this size. So this is working as a guard for us. And also let me increase the denoising amount because it wants to completely change everything. And let me queue prompt. Okay, it's cropping, and after that you can see it's trying to add some car in image. And if I queue the prompt, the last node, okay, you can see the mixed result. It have added a car, but actually it is not working with the image because it's completely an image that is not working with the perspective or of the parameter. Just the colors are similar. So I should do something. At first, let me show you. Okay, this is the area that I am getting. And if I make a preview from bbox preview, you can see this is my musket area. Okay, and the green line is the area that is extended to left and right. So in this case, I want to add some information around the image, maybe 300 pixel by 300 pixel by 300 pixel by 300 pixel. And let me again cue the mask. So you can see that it grow the area. So if I cue, you can see that I have more information from around the image. Now, if I do the processing, maybe, just maybe, it can do a better job for me, because having the information from surrounding is very important. Okay, still it is not working fine because we are using a normal checkpoint. It is not in paint. Here I have a realistic vision in paint version. Okay, and if I do a test with this checkpoint, maybe it can do a very better job, because these checkpoints are designed for working with inpainting, and you can see it here. So this is the difference between normal checkpoints and inpainting checkpoints. Inpainting checkpoints are able to work with the perspective, and it can get the information from the surrounding of the image. But still the quality is not fine. So let me use the SDXL. Okay, and also I have a unit. This is a unit file that you can download for the SDXL, and it will do the inpainting process for SDXL. This is a normal checkpoint, and this is the unit file. So just I will use the output of the model, and clip and the VAE will coming from this node. Also, it can work for me. Let me cue the prompt and check the result. Okay, this time you can see that I am doing the processing with SDXL version, and it has some better situation, but still is not something well. And this is the final composition. Every time it will be do automatically. And now let me do another thing. I want to use normal version of SD 1.5. It is not in painting. And I want to enable differential diffusion. And you know, for using the differential diffusion, you need some blur mask. And this was the mask that we was sending. Let me do a preview to the sampler, and it is not blur. So let me blur the mask by this node, layer mask grow from layer style, and increase the blurriness. Let me cue the prompt. Okay, it's better. And now let me connect the output of this node to InPaint model conditioning and enable the differential diffusion. And this is a normal checkpoint. But with the help of the differential diffusion, I think it can do a good job for us. I think I have the problem. Oh, the inverse mask is activated. I should disable that. And again, Cue the prompt. Okay. It's starting, but there is not any car here, so I should increase the weight. Okay, so by using the differential diffusion, you can see that we were able to add these two car to the image by better scale and better composition. But for blending, we have some problem, and I should fix that later. I will show you how to fix that. But as you can see here, maybe we need some more information, or maybe we can change the checkpoint with differential diffusion and inpainting checkpoint. Let's see that is it possible to increase the quality and the adaptivity. Not so much. And let me check that with STXL checkpoint. Okay, it should load the unit and also the checkpoint. And after that, we can see how it's working. Yes, actually it's better now, but still this is not working perfect and the car is not in a good scale. If I increase the top padding to see more information from the house, maybe it will be better. Because, for example, if I have this house with this window in the processing window, after that the checkpoint can take better decision to defining the scale of the objects. Okay, it's not too bad. And because with STXL and also differential diffusion, the edges are more similar with the original image. Also here we can get a better mixed result. Okay, and if you check this image, you can see it's with original size, but still we can see some problem here. Okay, and if we want to fix this problem, after that we should edit the mask that we are sending to restore crop. Okay, so I should make a copy from this mask grow node and add it here. Okay, this time instead of adjusting the blurring, I should increase the grow. The blurriness for this image was 70 pixel, so it will go 70 pixel up and 70 pixel down. So I will increase the grow, for example, to 70 pixel, and after that maybe we can get a better composition. Okay, you can see it. Oh, I have to connect the mask here. Now let me see what will be happen here. Okay, now it's a little better because it will increase the size of the mask with this node, and after that it will composite the image. But you can see that this area is coming from the processed image and it's not in very high quality, so maybe maybe you have to fix these small errors in Photoshop, but it can generate some better blending for us. So let me change my checkpoint to realistic vision normal and do another processing. And also I have to change my hyperstellura. It will be better. Okay, I should deslora. That is working better. Okay. And this is the final image, and it's a little have better blending.